Okay, everybody, welcome back. We're still moving here through chapter 2.5, measures of relative standing or measures of position, Math 235. In the past, we had been talking about how many standard deviations away from the mean is a piece of data. And so we did this last time just by recognizing things like if my mean is 100, my standard deviation is 15, then an IQ of 130 is, say, 2 standard deviations above average. So here's a calculation that we can use in order to find, in any case, in particular when I'm not exactly 2 deviations above or below, I can find exactly how many standard deviations away from the mean any point of data is, any value. And what that's called is the z-score. The z-score is literally the number of standard deviations that a given value is away from the mean. So what do I do when I want to find the z-score? I take my data value, whatever it happens to be. In this example up here, we can say the data value is 130. That's my point of data that I'm assessing. And I subtract the mean. And what this gives me, in my easy example, I take 130 minus 100, and of course that gives me 30. And that tells me exactly the distance from my value to the mean. And note that it could be plus or minus. So I take my data value minus the mean and I divide it by the standard deviation, because what I'm doing here is I'm seeing how many times does my standard deviation fit into this difference. So in my example over here, I take 130 minus 100, I divide by 15, that gives me 30 over 15, which is of course just 2. And this is consistent with our observation that a score of 130 is 2 standard deviations above 100. So given any point of value whatsoever, we apply this simple calculation. We take our data point, we subtract the mean, and we divide by the standard deviation. And this tells us more or less how far away from average that data value is. And it's important to remember that this can be a negative value. And of course what this indicates is that our value is actually below the mean. So for example, we saw that Howard Stern had an IQ, or excuse me, a SAT score of 826, and if you remember, the mean SAT score was 1026, and so if I find his z-score, how many standard deviations below average was Howard? He was 1, remember, because the standard deviation was 200, and we said he's exactly 1 standard deviation below average. And so the z-score should be what? Well, 826 minus 1026, that's minus 200. I divide by the standard deviation, that's 200, and I get minus 1. And the way I interpret this is more important than the number. This number means nothing if you don't understand what it means. What it means is that this score is exactly 1 standard deviation below, as indicated by the minus sign, below average. And that was what we saw when we looked at Howard's SAT. So the first important thing that we use z-scores is to give us a sense of how typical our data score is. We think about data scores, especially in a normal distribution, that occur around average, to be sort of typical. If the average IQ is 100 and I scored an IQ of 105, knowing how close this is to average can tell me if it's a typical or atypical z-score. But to do that, I don't just need the average, I need the standard deviation as well. So, for example, let's see how we compare 2 data values using something like z-scores. So I have 2 SAT scores. We have, again, true scores, at least if you believe what you read on the internet. Natalie Portman was a very smart actress. I believe she went to Harvard. I might be wrong about that. But her SAT score is reported to be 1440. And Bill Cosby had an SAT score of 500. So a very big difference here. So obviously it goes without saying that Natalie Portman did better on her SAT than Bill Cosby. But my question is, which of these is a more unusual score? Meaning if you're randomly selecting something like SAT scores, which one are you more likely to come across, a 1440 or a 500? Who is sort of further off the grid in this sense? Well, as a rule of thumb as to what's usual and unusual, it's fair English in some ways to say that if you get any score in any set of data that's more than 2 standard deviations away from the average, then this is an unusual score. And if you score beyond 3, this is extremely unusual. And so, given a situation like the one we just saw, what we can do is we can calculate the z-score for each of these people to get a sense of how unusual these scores are. The further away from average you are, the more unusual your score is. So, before we look at that green box, let's go back here and let's think, what is the actual z-score for each of these two SATs? So here's another question. Find the z-score for Cosby and find the z-score for Portman and tell me which one you think is more unusual. And so hopefully you're able to do this correctly, but if we just check, here's Natalie Portman on the left, and I went ahead and calculated the z-score associated with her SAT. So I took her data value, which was 1440, I subtracted the mean, which was 1026, and I divided by the standard deviation of 200. So the z-score associated with her SAT was 2.07. And then when we looked at Bill Cosby over here, his SAT score of 500, again, 500 minus 1026 over 200, that gave me negative 2.63. So my conclusion is that it was more unusual to see a score like Bill Cosby's than it was Natalie Portman's. He was further away from average than she was. In some sense, he was more bad than she was good. These are both fairly unusual scores. Natalie scored very high, Bill scored very low, but his was sort of more atypical than her score. And so what we're doing is we're comparing where they stand relative to the mean. And so I just want to do one more example here about using z-scores to determine how unusual a point of data is. So let's do this example here. And suppose that you're a nurse and you're testing the cholesterol levels in different patients, cholesterol measured in milligrams per 100 milliliters. And you know that the average male between 18 and 24, their cholesterol level is 178.1, and the standard deviation here is 40.7. True data values from the National Health Survey. So you have a male who's 21 years old, and he comes to you, and you test his cholesterol, and it comes out at 259.0. Now, would you say this is unusually high? Are you concerned with this level of cholesterol? How unusual is it? So, how will you answer this question? Think about it for a second, and then I'll show you. And so, hopefully you're able to understand exactly what was being asked here. When we're asking how unusual this score is, really we're just trying to assess how far away from average is it, what is the likelihood of this kind of score appearing when I look at a patient. And so, when the mean is 178.1 and the standard deviation is 40.7, what I need to do here is I need to go ahead and calculate the z-score. So a way of answering this question is answering what is the z-score for a patient who has a 259 cholesterol level. And to find the z-score, what you should have done is taken 259, subtracted 178.1. Notice that this number is positive, of course, because 259 is bigger than 178, so we're above average. And I divide by the standard deviation, 40.7. I punch that into my calculator, I get approximately 2, almost exactly. So this is a z-score of about 2. And remember what that means when your z-score, when you're 2 standard deviations above average, excuse me, we consider that to be a fairly unusual score. It's not extremely unusual, but it is pretty unusual. So if I'm a nurse, I might be concerned at this point, knowing that his cholesterol level was that high. So that's it for now. Next time we'll talk about percents and quartiles.